Good day, students. This is the Algebra 2 Introduction, Solving Absolute Value Equations. So the standard for this lesson today is ACED 1-1, and our learning target is to determine why solutions to a variety of absolute value equations make sense and contain more than one solution, or no solution. So by the ending of this lesson, you should be able to solve and answer this question: how can you solve an absolute value equation? So before we get into solving absolute value equations, let's first define what it is. So an absolute value equation differs from linear equations in that it may have two solutions. So this indicates what we call a disjunction, which is a mathematical statement created by connecting two other statements with the word or. So let's first look at an example of how we can solve an absolute value equation by graphing. So scroll down to your lesson notes and let's look at example number 1. So it says solve the following absolute equation by graphing. So we have 2 times the quantity of the absolute value of x minus 5 minus 4 equals 2. So the first step is to plot the function of f of x equals 2 times the quantity of x minus 5 minus 4 on the grid. So we have our h and we have our k, and remember we also have our slope. Okay, so h and k, that's going to end up being 5 comma negative 4, and our slope is 2. So 5, negative 4, so that means we're going to the right 5 units and down 4 units. So my vertex is here. That's my h comma k, or my 5 comma negative 4. And then remember our slope, we always go to the right. So our slope is positive, so it's a positive 2. So that means it's going to be opening upward. So we go 2 up. So if I'm at negative 4, then I go up to negative 2 and then over to the right 1. And then I go up 2 and over to the right 1. And I do the same thing on the left. So I'm going to go up 2, but then go over to the left 1. Up 2 over to the left 1. So we have enough information to now sketch our graph. So we have our graph that's going to look something like this. Okay. Now, the next step to graphing or to solving an absolute value equation by graphing is to plot the function now of g of x equals 2. So why are we doing g of x equals 2? Well, it says here in the function that the full function is equal to 2. So c is equal to 2 here. So we're going to plot the function of g of x is equal to 2. So where is 2 located? 2 is located here in the function. Well, let me make it a different color. Let's do blue. So 2 is located here. Remember, if I just have y equals 2 or f of x equals 2 or g of x equals 2, that means that the line is going to go through horizontally the point 2 on the y-axis. So that means I'm going to graph the line here of y equals 2. Now, if you recall, the absolute value function always has 2 values, right? So remember when we said absolute value function, if I take the absolute value of 5, that's going to equal 5. And if I take the absolute value of negative 5, it's also going to equal 5. Remember, absolute value is the distance from 0. So 5 and negative 5 will always give me the same value, even though they have 2 different signs. So the same is true here for absolute value equation. As you can see, we're going to have 2 answers here. So the line of g of x equals 2 reveals the 2 answers that this absolute value function has. It has the first point here, which is 2 comma 2. And it has the second point here that makes this statement true, and that's 8 comma 2. So we have 2 comma 2 and we have 8 comma 2. So what does that tell us as far as our solution is concerned? Well, since 2 is already on the y, that means that our actual solution points, the points that we can plug in for x that's going to make the solution true, is our x coordinates, 2 and 8. So we write the solution of the equation as a disjunction. That means the two solutions that we can have for this absolute value function is 2, x equals 2, or x equals 8. So those are our solutions for the absolute value equation. All right, so let's look at example number 2, where it says solve the absolute value equation algebraically and then graph the solution on the number line. So when we solve an absolute value equation algebraically, we have to first isolate the absolute value expression on one side of the equation, the same way we would do to isolate a variable in a linear function. So the rule is that if x is equal to a, absolute value of x is equal to a, where a is positive, then that means x is either equal to a or x is equal to negative a. So that's our disjunction. Remember, we're going to have two solutions, okay? So this means that for the first step to solve this absolute value function, we would have to isolate our absolute value expression. So to do that, we have to add 2 to both sides. So when we have 2 added to both sides, we are left with 21 on the right, and everything else, the 3 times the absolute value of x, 4x minus 5 on the left, remains the same. Then we would go about this like we would if we were solving a linear equation. We would then divide both sides by 3, so the left remains the absolute value of 4x minus 5. 21 divided by 3 gives us 7. And then we would have to write the equation, rewrite the absolute value in 2 equations, because remember, there's a disjunction. Either we have one equation with the absolute value of that equation equals some number that's positive, and then another one where that some number is now the negative of that number. So we have 4x minus 5 equals 7. And then we also have 4x minus 5 equals negative 7. So now we would just solve like we would normally do for both equations now. So obviously, to isolate our variable, we would have to add x to both sides of both of these equations. So on the equation on the left, if I add 5, I get 12. And the equation on the right, if I add 5, I get a negative 2. And then again, we're solving for x. So again, we are now dividing both sides by 4. So if I divide 4 on the equation on the left, I get 3. And if I divide 4 on the equation on the right, I get negative 1/2. Right? So now we have our 2 solutions. Remember, absolute value equations, the most have 2 solutions. So when I graph this, I have 3 here. My absolute value function equals 3. And I also have negative 1/2. So negative 1/2 would be here in between 0 and negative 1. So those are my 2 solutions for my absolute value equation. Okay, so let's look at example number 3. We have part A and part B. We're going to isolate the absolute value expression in each equation to determine if the equation can be solved. If so, we're going to finish the solution. If not, we're going to write no solution. So we stated that there were 3 cases in solving an absolute value equation as far as its results. An absolute value equation can either have 2 solutions or more than 1 solution. It can have 1 solution or it can have no solution. So when an absolute value is equal to 0, there is 1 solution because 0 is its own opposite. So what does that mean? Remember, absolute value means that we're looking at the value's distance away from 0. So if I said, what's the distance of 0 from 0? Well, obviously, it's going to be itself. It's only going to have 1 solution because 0 is both positive and negative. Right? So it's only going to, so absolute value of any function that's equal to 0 is going to always be 1 solution. But when the absolute value expression is equal to a negative number, there is no solution, because remember, absolute values can never be negative. So whether I plug in a positive number into an absolute value or a negative number, remember, absolute value consists of distance away from 0, and distance is always positive. So the value of any number in the absolute value will always be positive. Therefore, it can never be negative. So let's look at these two cases. Part A. We have the absolute value equation, -5 times the absolute value of x plus 1 plus 2 equals 12. And we're going to solve for x and see what type of value we get. So obviously we have to first subtract 2 on both sides, because remember, we have to isolate the absolute value equation. So when I do that, I have on the left -5 times the absolute value of x plus 1, and on the right I have 10. Okay. The next step would be to divide both sides by -5 to get the absolute value by itself. So when I do that, -5 goes into +10, -2 times. As you can see, the absolute values are equal to a negative number, and we know absolute values are never negative. So if it's a negative number that the absolute value function is equal to, then we know that there is no solution for this problem. All right, let's look at part B. So remember, from part A, when the absolute value is equal to 0, we know it's always going to have a 1 solution, and when the absolute value expression is equal to a negative number, it's always going to be no solution. Okay, so let's just keep that in mind for part B. So we have the absolute value equation, 3/5 times the absolute value of x, 2x minus 4 minus 3 equals -3. So again, we isolate the absolute value expression by adding 3 to both sides. So when we add 3 to both sides, we are left with 3/5 times the absolute value of 2x minus 4 equals 0. So obviously we know if it's equal to 0, it's going to have 1 solution. So we multiply both sides by the reciprocal of 3/5, which is 5/3. On the left, it cancels everything out, leaving us with the absolute value of 2x minus 4. And on the left, 0 times anything is just 0. So remember, when we are dealing with absolute value equations, we write it as a disjunction of two equations. But because 0 is its own opposite, we don't need to write a disjunction. We can just keep it as one equation, because we already know it's going to have one solution. So we rewrite the absolute value equation as 2x minus 4 equals 0. And now we're just solving for x. So we add 4 on both sides. So when we add 4, we get 2x equals 4. And then, of course, we're going to divide both sides by 2 because we're solving for x. So when that happens, we get x is equal to 2. So as you can see, we got our one solution. And when we graph it, we just plot the point right here on the line as x equals 2. Okay guys, so we have reached the U-try of the lesson. So your responsibility now is to go to the quizzes U-try game to go ahead and try out each problem. And you're going to enter your answer as you receive them. And then you're going to come back. That means you're going to pause the video now, put your answer in quizzes, and then come back to see if you're on the right track for each one. All right, so example number 1 says solve the absolute value equation algebraically and then graph the solution on a number line. So remember, when we are solving an absolute value equation algebraically, we are isolating the absolute value expression. So we're trying to get the whole absolute, whatever's inside the absolute value expression by itself. So the first thing we have to do is multiply both sides by the reciprocal of 1/2, which is 2 over 1. On the left, that cancels everything out here. So we are left with that absolute value expression, absolute value of x plus 2 on the left. On the right, 10 times 2 over 1, that gives us 20. So as you can see, 20 is a positive number. It's not negative, nor is it 0. So that tells us it's going to be a disjunction. So we're going to have two equations with the OR statement, right? So we got that OR statement in the middle. So we're going to have x plus 2 equals 20, and then we're going to have x plus 2 equals negative 20. So to solve, we're just now isolating x. So to isolate x for both equations, we're going to subtract both sides of the equations by 2. So for the equation on the left, we get 18, x equals 18. And for the equation on the right, we get x is equal to negative 22. So on our number line here, we are graphing both solutions. So we have x is equal to 18. So that would be right around here. We have x equal to 18. And then the equation on the right, or the solution on the right, we have x is equal to negative 22. So negative 22 would put us here. X equals negative 22. And that is example number 1. Okay, so again, for example number 2, go ahead and pause the video, work it out on your own in quizzes, and then come back to see the explanation. All right, so number 2 says solve the absolute value equation algebraically. Graph the solution on a number line. So again, we work this out by subtracting 5 on both sides. So that means we're left with negative 2 times the absolute value of 3x minus 6 equals negative 4. So that already tells me right there something is going to take place, but we're not done yet. You're probably saying, oh, it's equal to a negative number, so we're going to have no solution. Well, guys, wait. We still got to divide by a negative 2. Right? So we're going to have the absolute value of 3x minus 6 equals, and now that negative becomes a positive because negative 4 divided by negative 2 just gives me 2. So, oh, look, we're back in business. We still have a disjunction, 2 separate equations. So equation on the left, 3x minus 6, that's going to be equal to 2. Equation on the right, 3x minus 6 is going to be equal to a negative 2. And here we just solve like we normally would. We're going to add 6 on both sides. So when we add 6 on both sides, I'm just going to write it out so you guys can see it. We're going to have a 3x equals 8. And then on the right, we're going to have a 3x equals 4. And of course, we got to divide both sides by 3 for both the equation on the left and right. So we are left with 8 over 3. And we are also left with x equals 4/3. Okay. So if we are plotting 8 over 3, so 8 over 3 approximately is like, what, 2 1/3. So we're looking at maybe somewhere here. And then 4 over 3 is approximately 1 1/3. So we're looking at somewhere probably here. So these are our two solutions on the coordinate plane. On the number line, sorry. All right, so example number 3, again, work it out in your notebook on your own, put your response in quizzes, and then come back to see if you worked out everything correctly. So number 3 says isolate the absolute value expression and each equation to determine if the equation can be solved. If so, finish the solution. If not, write no solution. So again, we are working this out like we normally work it out by isolating the absolute value expression. So we would have to subtract 7 on both sides. And when we subtract 7 on both sides, we get 3 times the absolute value of 1/2 x plus 5. And that's going to be equal to 5 minus 7 gives me a negative 2. Right then and there, that tells me, looks like we might have a no solution because the absolute value is equal to a negative. But let's first divide both by 3. Because remember, we got that 3 on the outside of the absolute value expression. And then, of course, the 3 doesn't make a difference because the 3 is positive. So I'm left with the absolute value of 1/2 x plus 5 equals a negative 2/3. Since the absolute value expression is equal to a negative number, that automatically tells me I have no solution here. All right, so we are down to the last you try example. So again, work it out in your notebooks, put your response in quizzes, and then come back to see if you were on the right track. So number 4, it says, isolate the absolute value expression in each equation to determine if the equation can be solved. If so, finish the solution. If not, write no solution. So again, we are solving this to isolate the absolute value expression by subtracting 7 on both sides. So I'm left with 9 times the absolute value of 4/3 x minus 2 equals 7 minus 7 gives me 0. So automatically I know I'm going to have one solution. That's correct. So we are going to continue by isolating the absolute value expression by divided by 9. When I do that, on the left I have the absolute value of 4/3 x minus 2. On the right I have 0. And then if I continue with solving, remember I turn this into just one equation because remember 0 is the opposite of itself, so I don't need to do the disjunction. So I'm going to add 2 on both sides, which leaves me with 4/3 x equals 2. And then I'm going to multiply by the reciprocal. So when I do that, that cancels out on the right. And on the left, I have x is equal to 2 times 3 gives me 6. So I have 6 over 4, which reduces to 3/2. So I have x is equal to 3/2. And 3/2 we know is 1.5. So my answer is here. All right, guys, so that concludes the examples for today's lesson. Let's see if we can answer this essential question. So remember, the question was, how can you solve an absolute value equation? Well, the first thing that we have to do is isolate the absolute value expression. Once we isolate the absolute value expressions, then we have to write 2 related equations with a disjunction, also known as an OR statement. All right, so remember, any absolute value equation, isolate the absolute value expression first. Then you're going to write 2 equations with a disjunction. Remember, one equation has the positive of that disjunction, and the other one has the negative of that disjunction, or the OR statement. All right, so that wraps up this lesson for today. Your responsibility now is to go to iExcel and complete your class practice, which can be found on solving absolute value equations. The code is here, 9LF, and you also have the link at the bottom of your notebook for this lesson. Enjoy, guys, and I will see you next class.